Okay, students, so this week we are combining both exponential expressions and radical expressions. So I'm going to do a few examples just to get you going here, but hopefully you already are comfortable with this information because this is supposed to be reviewing from previous weeks, okay? All right, so let's do some examples. So the first thing, we remember some of these rules for exponents, right? So that's so when you multiply, you add the exponent. So that's 4 to the 6th power. Everything inside the parentheses raised to 0 equals 1, right? When you are dividing, you are subtracting the exponent. So that's 5 minus 1, right? There's only 1 3, so 5 minus 1, that is 3 to the 4th power. When you have a power of a power, you are multiplying the powers. So that's 4 to the negative 4 times negative 2. That's positive 8. Okay, what else do we say? So here you're adding, so that's negative 1 plus 3. That's subtracting, so that's with negative exponents, so that's negative 5 minus 0, that's negative 5. So that is 4 to the negative 5th power, which you bring down by put a 1 on the top as a numerator. So that's 5 to the 5th power. It becomes positive. So that's a bunch of rules that we went through, each of them. And then we combined them and we started with a little bit more involved problems. So let's do a couple here. Let's see this one. So you have to follow the same rules, right? So first multiply the exponents here. So that's 2 to the negative 4 over 2. And then so negative 4 minus 1, because you're subtracting, that's 2 to the negative 3. And then you put it under a 1 to have the exponent positive. What else we did? Something like that. We multiply the coefficients, which is 2 times 2. That's 4. And then we add the exponents, right? Because you're multiplying. So that's 8. That's 3 plus 4. That's 8 to the 7th power. Same thing here. So that's 5 times 1. That's 5. And then you add the exponents. That's to the 6th power. This is something like this quick. So that's, we solve this one first. So that's 2 to the 2nd power. And then 2 times 3, that's 2 to the 6th power times 2 to the 4th power. And then we can just add and then subtract the exponents. So let's add the exponents here. That is 2 to the 2nd power and 2 to the 10th, right? Because you're adding. And then you subtract the exponents. So minus 10 is negative 8. That's 2 to the negative 8. And then you put it under a 1 to simplify. 1 over 2, and it becomes positive. So that's a combination of different ones where you have the product, you have the power rule, and then you have the quotient rule. So that's a good one right there. Anyways, that's pretty much with zeros here. So this becomes 1, right? So that's 1. This becomes 1, right? But this one doesn't, right? That's 4 to the negative 4. So 1 times 4 to the negative 4. So 1 times 4 to the negative 4 is 4 to the negative 4 over 1, right? And which is 4 to the negative 4. But then you have to flip it, right? Because then it becomes 1 over 4 to the 4th power. Okay. All right, let's do this one. Actually, let's go into our radical expressions. All right, so the way we did this is we know that x to the x squared, the square root of x squared will be x, right? So knowing that rule, each pair, when I see a pair, I can break that down and then take the variable out. So let's remember this. So we said that we have to find two numbers that one of them is a perfect square. So let's do that. This one would be 25. So 5 times 25, right? 5 times 25. And then we have an n here. So we can only take the square root of this one, right? So we take a 5 out, and then we are left with 5n inside. And that's the answer right there. Okay. All right, what else did we say? We said that 512 divides by, or which one do we do? Well, the ones that can have actually like the square roots, perfect squares, and you can just take out the number. So that's 10 times 10, right? That's 10. So you take 10 out, and then just remember that we can break this, right, into b squared and v, and one more v, right? That's 3 plus 1. That's 2 plus 1 is 3. Then we can just take the square root of this one. So that's 10. And then take the square root of v, which is v, and then just leave one v in there. All right. This one, we have, what is it? 5 times 9 times p squared. So we can take the square root of this one, and we leave the 5 in there. So that's 3, and then times p times the square root of 5. So that's the answer right there. Let's see. For this one, we said that it was something like what? 16, right? It was 16. So we have 16 times how much? Let's see. Let me get my calculator here. Sorry. So 16. So 80 divided by 16, that is 5. So we said that 5 times 16. And then you have 3p. So you have p squared plus p1, right? We can take the square root of this one and this one. So we have 4, and then p, and then we leave inside whatever we can't take the square of, which is 5p. Okay. All right, we said 2 times 100 here. We can do that. 3 times 25 here. So this one would be, so we have 3 times 25, and then we have times x squared times y. So we can take the square root of this, and we're left with 3y inside. So that's 5x times 3y, and square root of 3y. Okay, something like this would be, well, you can take the square root of 64, so that's 8, and then you're left with m, so break them in pairs, right? So that's 2 times m, and then n times n squared times n, so that's 3 m's and 3 n's, right? That's what you have here. And then you can take the square root of this one, and you're left with m and 1m and 1n inside the square root. So that's 8m, and then n times the square root of m n. On the 4, you can take 2 out. So that is 2 times 100, and then which is a square, perfect square, and then you have m squared times m squared. That's 2 of them, right? 2 pairs, and then times n. So you can take the square root of this, and this. So you get 10m squared, right? You get 2m's, and then times 2 times the square root of 2, and then n. And that's the answer right there. Okay. All right. Let's see. I think we said this one was 3 times 49 and 216. 216, 6 times 36. So on this one is 6 times 36, and then k squared times k squared, because that's total of 4. Then you take the square root of each here, so you get 6 And then k squared, right? Because there's 2 of them. You take 2, so that's 6. That's it. That's the answer right there. And for 512, we said that it was 2 times 56. So on this one would be 2 times 256, right? 256, which is a perfect square. And then we have 3m, so that's m. We break them in pairs, right? So that's total of 3. And then we take the square root of this, and then we get, what, 16, and then m, and then the square root of whatever you can't take out, which is 2m. And that's it. All right, I hope this helps.